science fans, welcome back to Science Fun with Austin. Today we're going to be taking a look at something interesting. It's called a ferrofluid. And a ferrofluid is basically a suspension of really tightly magnetic particles in some kind of fluid. Typically the particles are iron, so we use a fluid like oil because, iron and water, we don't really need a science fun to figure that one out. I purchased mine on Amazon. You can actually make a ferrofluid fairly easily with magnetic toner and vegetable oil. That costs about as much as just buying it on Amazon anyway. And there's also an alternate method which involves a whole bunch of cassette tapes, acetone, and vegetable oil. But for the life of me, I really don't know anyone who has a whole bunch of cassettes around anymore. Anyway, the stuff stains really well, so I'm going to change shirts and see what we can do with it. So the cool thing about a ferrofluid is that in the absence of a magnetic field, it acts like pretty much any other fairly thick liquid. Your behavior is governed by things like viscosity, gravity, and surface tension. But when in the presence of a magnetic field, the behavior of the iron particles begins to dominate. You can see here how the ferrofluid is reacting to having a small magnet around. You can actually see the little spikes. What the spikes represent are where magnetic field lines are entering and leaving the surface of the ferrofluid. And you can see there's enough attraction between the nanoparticles and the magnet to hold the magnet on the bottom of this plastic cup. So here's the behavior of the ferrofluid with a little bigger magnet. This is actually, if you take a look, a spherical magnet, which produces a pretty interesting pattern in the fluid. You can see as we rotate the ball, we're at a pole of the magnet, in between poles, and on the opposite pole. And as kind of a neat bonus, you can see we can hold a fairly substantial magnet up with a fairly limited amount of ferrofluid. Okay, another interesting property we can show here is how magnetic force lines travel through a metallic object. Here we have just a plain old washer and ball bearing in a tub of ferrofluid, and you see it's just acting like a regular old pot of oil. When we put a fairly potent magnet on there, you see a pretty immediate response. In addition, you can see the little bit of ferrofluid that we've that has splashed out is following the magnet. And we're now capable of attracting a rag with the ferrofluid. And you can see how the magnetic force lines go through the ball bearing and are also proceeding around the washer. So far we've actually tried to keep the magnet separated from the ferrofluid. If you actually put it in there, you see some interesting behavior. First off, you can see we don't even have to actually touch the jar to have the... we don't actually have to touch the surface to have the fluid make its way up onto the magnet. And when we actually have the magnetic ball in the ferrofluid, it glides around almost effortlessly. It is a very low friction contact. This is actually used in a few production bearings. Just a closer look at the pattern the fluid forms when it's in direct contact with the magnet. Now what do I do? It's like the coolest thing ever. For fun, we have a magnet here and our original magnet, and we'll watch the interaction between the two. You see when the fluid gets strong enough, it actually flies across the gap to the other magnet. There's actually some talk of using this as a CubeSat attitude control mechanism by using a magnetic field to fling ferrofluid away from the CubeSat and provide a reaction force. And actually the second magnet has pulled all of the fluid through the paper towel into direct contact with the surface, which was pretty cool. So you can see it scoots around almost without friction. And you can see the fluid going through the paper towel, but being largely unaffected by it as we drag it over the surface of the magnet. It's pretty darn neat. Alright, we have one more test environment left for our ferrofluid. This one should be an alternating electric and magnetic field known as a microwave. And let's see what actually happens. Interestingly enough, the answer appears to be not a whole heck of a lot. So the bottle got a little bit on the warm side, but as you'd expect. But not a whole lot else happened. So apparently the ferrofluid particles still absorb microwaves, but they're small enough not to react like the steel wool did. Alright, I think we managed to have a pretty good amount of fun with the ferrofluid today. Turns out it does make a little bit of a mess, so you might want to be careful with that. But we got to see how the iron nanoparticle oil suspension reacted to a few different magnetic fields. And we also tested it in the Science Fun microwave. Unlike the other fine iron materials like steel wool that we put in there, the ferrofluid didn't do much more than just kind of heat up. Probably much to the benefit of the Science Fun microwave. Well, I hope you enjoyed it, and until next time, have some science fun, science fans.